Okay, so for item 54, we're given a diagram, and it says that in the diagram, A, B, and C, D are parallel. Which of the following best describes the relationship between X and Y? So X and Y, okay, so when lines are parallel, the alternate interior angles are equal. And you can eye it and see, even though it's not drawn to scale. So X is equal to Y. That is A. Okay, so for number 55, we're given an isosceles triangle, and it says that in the triangle the value of x is, so the angles in a triangle all add up to 180. So we're going to have 180 minus 30 minus 30 to get the x. So that is equal to 180 minus 60, which is equal to 120. Sorry, 120. That is C. Okay, so for number 56, we're told that the image of a point, so the point is P, that's negative 2 comma 3, under a translation 3 4. So we want the image under the translation. So when we're doing a translation now, all you have to do is you're going to increase the x value by 3, and you're going to increase the y value by 4. So just increase the x value by 3 and increase the y value by 4. So now negative 2, when you increase it by 3, is going to go to positive 1. Okay? 3, when you increase it by 4, is going to be 7. And that is D. Diagram above, the line CD is the image of AB. So this is the image. This is the original. This is the image of AB after a rotation through 90 degrees, center O. So let us eliminate. Is it a rotation of 90 degrees through the center? Just by looking at it, no, it is not. Is it a reflection in the y-axis? So a way you can know reflections, this is my favorite one, is just by folding your exam paper or any paper, and you realize that if they meet up, it would be a reflection. So the answer is B. But for the sake of this video, let us continue. Is it a translation by vector negative 4 8? So this is the original one, and the coordinates of this are 4 8. No, it is not. You can add the translation vector to the original and you will see that. Is it a reflection on the x-axis? So this is the x-axis. If you fold the paper, it does not go down there. So it is a reflection in the y-axis, because it basically, if you were supposed to fold the paper on the y-axis, then they would meet up. Okay, so number 58, we're hearing about similar triangles. If you do not know what similar triangles are, they're basically triangles that are similar. Okay, so when you're talking about similar triangles, we need something called a similarity ratio. Similarity ratio. So we know that triangle 1, we're going to call this one number 1, and we're going to call this one number 2. It is 6 centimeters on the base, and this one is 3 centimeters on the base. So we're basically trying to find the ratio of the sizes. It should be 2 to 1. So this one is twice the length of the other one. The ratio is 2 to 1 because one side is twice the length of the other side. Now, what we do with this information is that we have something called ratio of areas. Now, we are told that the area of triangle 1 is equal to 20 centimeters squared, right? To find the ratio of the areas, we need to do 6 squared over 3 squared, and that is equal to 36 over 9. So therefore, the areas are in the ratio 4 to 1. So we're told that the area of the first one is 20 centimeters. So what would the area of the second one be? You can cross multiply and the answer will be 5, and that is C. I will insert a clip of the formulas for the ratio of areas. So So we're given two triangles and we're asked to find the scale factor of the enlargement. Now, how do we find the scale factor of an enlargement? So the way how I do this is that I count the units. So on the smaller triangle, we realize that we have 2 units. On the larger triangle, we have 1, 2, 3, 4. Therefore, this one is 2 times the size of this one. So therefore, the scale factor of the enlargement is 2. We can also do it from the bottom as well. So we have 1 unit here and we have 2 here. So therefore, the scale factor of the enlargement would be 2 as well. So that's 2 ways. So for this question, we're given a diagram and it says that the angle of depression of a point X from Z is 30 degrees. If X is 10 meters from Y, the height of YZ in meters is. So first things first, we have to identify what we want, and we want the height right here. Now, we're given that the angle here, that is, so we also want the angle that is right here. There are 2 ways that you can find this. You can say, okay, all the angles in a triangle are supposed to add up to 180, and this is 90. Right here is 30. So since this is a right angle, then if this is 30, this must be 60. If this is 60 and this is 90, then this must be 30. Or you can say for the Z angle, the adjacent angles would be equal. So that is how you could also get the 30. Now, this is the angle that we're paying attention to. So we all remember so, ka, toa, right? So what we need is the opposite from the angle. What we have is the adjacent, right? So now we're going to take toa. Why? Because this is the only one of these 3 formulas that takes into account what we need. So these are talking about hypotenuse. We don't have any hypotenuse or anything like that. So toa. This is saying that tan of the angle is equal to opposite over adjacent. And this is opposite from the angle. So tan 30 is equal to opposite, which is the side, over adjacent, which is 10. This implies that opposite is equal to tan 30.